The night sky is a vast and beautiful mystery. For thousands of years we have looked up at the stars and wondered, what is out there? Are we alone? These are some of the oldest questions we have ever asked. We built telescopes to peer deeper into the darkness. We saw planets and galaxies far away. But looking is not the same as going there. To truly understand these distant worlds, we needed to reach out. We needed to send messengers to explore for us. These messengers are our space probes. They are incredible machines built with human curiosity and ingenuity. They travel for years, sometimes decades, across the cold, empty void of space. These robotic explorers are our eyes and ears in the cosmos. What these probes have found has been nothing short of revolutionary. They have consistently shattered our expectations and rewritten our textbooks. The universe, it turns out, is far stranger and more wonderful than we ever imagined. Our journey begins with the Voyager 1 probe. In 1979, it flew past the giant planet Jupiter. It also took a close look at Jupiter's moons. One of these moons was called Io. Before Voyager, scientists thought moons were mostly dead, quiet places. They expected to see a cold, cratered world, much like our own moon. They believed that only larger bodies like planets could have enough internal heat to be geologically active. But Io was not quiet at all. It was a world of fire and chaos. Voyager 1 sent back images that stunned the scientific community. The pictures showed a surface covered in yellow, red, and black splotches. The answer was found in Jupiter's immense gravity. Io is caught in a gravitational tug-of-war. It is pulled by Jupiter and also by the other large moons, Europa and Ganymede. This constant pulling and squeezing flexes the moon's interior. The discovery of volcanoes on Io changed everything. It showed us that moons were not necessarily dead worlds. It introduced a new way for a celestial body to generate heat and stay active. This had huge implications for the search for life. After the fiery surprise of Io, Jupiter's system had another secret to share. This one came from another of its large moons, Europa. Seen from a distance, Europa looks very different from Io. It is a bright, white world, covered in a smooth shell of ice. When the Voyager probes flew by, they saw this strange surface. But it was the Galileo probe, which orbited Jupiter from 1995 to 2003, that gave us a much closer look. Galileo's data suggested something incredible was hidden beneath that icy shell. The magnetometer detected a strange signal. The best explanation was that there was a layer of something that conducts electricity beneath the ice. And the most likely candidate was a vast ocean of salty liquid water. The evidence pointed to a global ocean, perhaps 100 kilometers deep, hidden from view. This ocean would contain more water than all of Earth's oceans combined. The idea of a hidden ocean was a bombshell. Europa's hidden ocean is now one of the most exciting places in the solar system to search for life. It has the three key ingredients that scientists believe are necessary for life: liquid water, a source of energy from tidal heating, and the right chemical elements. For a long time, Saturn's largest moon, Titan, was a mystery. It is the only moon in our solar system with a thick, dense atmosphere. This atmosphere is so hazy that it completely hides the surface from view. The truth, revealed by the incredible Cassini-Huygens mission, was stranger and more familiar than anyone expected. The Cassini spacecraft orbited Saturn for 13 years, and in 2005, it delivered a small probe called Huygens right onto Titan's surface. As the Huygens probe descended through the thick clouds, it sent back amazing pictures and data. It revealed a landscape that looked eerily like Earth. There were river channels, shorelines, and vast dark plains. The data it sent back confirmed that the ground was wet, but not with water. On Titan, it is far too cold for liquid water to exist. Instead, the liquid on Titan is methane and ethane, which are gases on Earth, but liquids at Titan's frigid temperatures. Cassini's powerful radar then spent years mapping the surface. Near the North and South poles, there were huge, dark, smooth patches. These were lakes and seas. There was Kraken Mare, a sea larger than all of North America's Great Lakes combined. The planet Saturn is famous for its beautiful rings, but it holds another, much stranger, mystery. This mystery is a gigantic storm at its North Pole. It is not just any storm, it is a hexagon, a perfect six-sided shape, wider than two Earths put together. This bizarre weather pattern was first spotted by the Voyager probes in the 1980s. The images were low resolution, but the strange, angular shape was unmistakable. Scientists were baffled. The answer came when the Cassini probe arrived at Saturn in 2004. As the seasons changed and the North Pole emerged from years of winter darkness, Cassini saw it clearly. The hexagon was still there. It was a stable, long-lasting feature of Saturn's atmosphere. Scientists on Earth tried to replicate the phenomenon in laboratories. They used spinning tanks of fluid to simulate Saturn's atmosphere. They found that under certain conditions, when a fluid rotates at different speeds at different latitudes, geometric shapes can form. The hexagon of Saturn is a beautiful and humbling discovery. It reminds us that our understanding of how planets work is still incomplete. It shows that even the gas giants have intricate and mysterious dynamics. For over 80 years after its discovery, Pluto was just a faint, fuzzy point of light. It was the most distant planet in our solar system, a tiny, mysterious world. Most scientists expected it to be a simple, frozen, dead world. In 2015, the New Horizons probe flew past Pluto, giving us our first ever close-up look. What it revealed was not a dead world, but a place of stunning beauty and surprising activity. The most shocking feature New Horizons discovered was a huge, heart-shaped plane on Pluto's surface. This feature, named Tombor Regio, was unlike anything scientists expected. The western lobe of the heart was incredibly smooth. It had almost no impact craters. A lack of craters means that a surface is young. It means that something has been erasing the craters. On Pluto, it meant that the dwarf planet was geologically active, right now. Scientists believe this vast sheet of nitrogen ice is slowly churning. It behaves like a giant lava lamp. This process constantly renews the surface over millions of years, smoothing it over and erasing any craters that form. Our sun is the star at the center of our solar system. It gives us light and warmth, making life on Earth possible. But it is also a violent and mysterious place. One of its greatest mysteries is the corona, the sun's outer atmosphere. The corona is incredibly hot. It reaches temperatures of millions of degrees Celsius, which is hundreds of times hotter than the sun's visible surface below. This is a huge puzzle. It's like walking away from a bonfire and feeling it get hotter instead of colder. To solve this mystery, we had to do something that sounds impossible. We had to go there. We had to touch the sun. This is the mission of the Parker Solar Probe, which launched in 2018. It is protected by a revolutionary carbon composite heat shield. This shield keeps the probe's instruments at a comfortable room temperature, even while the shield itself is heated to over 1,300 degrees Celsius. The Parker Solar Probe has already made incredible discoveries. It discovered bizarre S-shaped kinks in the sun's magnetic field called switchbacks. These switchbacks seem to be very common, and they carry a huge amount of energy. Each of these shocking discoveries has left a powerful legacy. They have not just given us answers, they have given us better, deeper questions. The volcanoes of Io showed us that moons can be geologically active. This is the true power of scientific exploration. It is a process that expands our imagination. Before Voyager, we could not have imagined a world as hellish as Io. Before Cassini, we could not have conceived of a place with methane rain and rivers like Titan. The impact of these discoveries goes far beyond astronomy. They change how we see ourselves. When we discover a possible ocean on Europa, it makes us think about the preciousness of our own oceans. These missions are a testament to what we can achieve when we work together and push the boundaries of technology. They are a source of inspiration, showing us that with curiosity and determination, we can reach out and touch the stars. But for every answer we find, new mysteries appear. How deep is Europa's ocean? What is at the bottom of Titan's seas? What strange chemistry is happening on Pluto? These questions are the fuel for the next generation of explorers. We live in a remarkable time. We are the first generation in history to see these distant worlds up close. So why must we continue to explore? We explore because it is in our nature. We are a curious species. The journey is endless. The universe is vast, and we have only just begun to scratch the surface. We must continue to send our silent messengers out into the great, beautiful darkness, because the more we learn about the universe, the more we learn about ourselves.